All right, so what we're going to be doing now is we're going to go a little bit more in depth to how the scans work and kind of talk about the primary scan types before we get too far into all the different flags. And first up is obviously going to be TCP Connect scan because that's the most fundamental scan. We'll compare that to a couple others. But the main thing is I want you to get your head wrapped around these different scan types and what they're actually doing as far as the scans that are going in and coming out. To start with, we have to be able to differentiate between the primary flags, which determines the type of scan that we're doing, and then secondary flags, which determine things like how fast you scan or how slow you scan or how big your packets are or whether it's a verbose scan or not. These are secondary things. So what we'll do is we'll first look at some primary flags, which would be the different scan types, and also look at the packet capture to identify what that specific type of scan is doing. So let's go through these. First, we're going to start with the TCP Connect scan. And of course, we're going to be scanning our .4 target over here that we looked at. And we will focus on port 80. And as always, I like to have a capture running here. And hopefully you'll do the same as you practice. And we're just going to do a filter between these two. So let's do that TCP Connect scan. The way you force that is little s big T, like so. So when you see that, it means that the scanner is completing the TCP three-way handshake. If we go look over at the victim, we can clearly see that that's exactly what happened. NMAP from the Linux machine sent a TCP packet. It's a SYN packet. The response was a SYN ACK, and then the response from that was an ACK. So right there is your three-way handshake, and then NMAP sent a reset to close that session. So very basic, very fundamental type of scan. Next, we'll look at, and let's just clear this. And we'll start over. For the next scan, we're going to do what we call a Maimon scan, okay? And with the Maimon scan, you give it the little s big M, and notice it comes back and tells us that the port is closed, even though we know that it's open from the previous scan. Now, there's a few things I want to dive into on that point. One, the only operating system that regularly responds that way to a Maimon scan, a Fin scan, a Christmas scan, or a Null scan is Windows. So you can pretty much bet your last dime that this is probably a Windows machine based on the fact that it responded to a state of closed to the Maimon scan, even though you know the port is open. Now, what types of flags were set in the TCP header with the Maimon scan? Let's go look. You can see that the flags that were set were Fin and ACK. So the Maimon scan, little s big M, sets a Fin and an ACK. And then the response that came back was a reset. Now, the reason that is because you should not ever lead, or your first packet to a port should not ever be a Fin and an ACK flag set. Since that's out of sequence, the normal sequence should always start with a SYN, then the TCP RFC state that a reset should be sent. Okay, so that's why you're getting a reset back. In this case, Windows responds that way, whereas other OSs may not. Now, the next scan that we're going to look at, and again, we're dealing with primary flags here, which dictates the type of scan. We're going to do a SN. Now, the capital N in the SN means null. So what would you guess, which flags would you think would be set in a null scan? How about none, right? So if we run that scan, we can see again, since it's what we call an inverse scan, we do get back a response of close, even though we know the port is open. If we go check, we can see that indeed what happened is NMAP sent this packet right here with no flags. That's why we see none there. And really, when we say no flags are set, if you drill down into layer 4, which is a transport layer, which is where TCP lives, and we drill into that header, what you see is the flags that have a 1 bit are none. This is what makes it a null scan, because none of the flags are turned on. If there was a flag that was turned on, it'd have a 1 beside it. For example, if we went back up and looked at the Maimon scan that happened first, we look at the headers, you can see there's a 1 for fin and a 1 for ACK, which makes those flags both be on. Okay, so that's how we know that's what's going on there. Now that's the Maimon, that's the null scan. Another one that you've probably heard a lot about, and we're going to have to look at 2 tools for this one because there's a lot of confusion in the industry about this one. A Christmas scan, okay? So we do that with NMAP with a little s, big X, and let's start the capture over here, because I really want you to understand this. Now, it responds like the null and like the Maimon to a state of closed, even though we know it's open, okay? But look at something that's interesting here. The flags that are set are fin, push, and urgent. So at a minimal, that makes it a Christmas scan. But if you look at some of the documentation out there that you read on the internet and other places, you will hear people say things like, well, a Christmas scan is when all the flags are set or all the primary flags are set. Well, they're both right. It's just that the minimal is fin, push, and urge. But if you set all of them, that includes fin, push, and urge as well. As a matter of fact, watch this. If we go and actually set urgent, reset, and ACK, if we set all those using hping, and we hit that target, as far as that machine is concerned, it's still a Christmas scan. Let me prove it to you. We're going to now run Snort as an intrusion detection system. And I'm going to run it in IDS mode, full intrusion detection mode. And I'm going to make it log these so that we can look at it in PCAP format and see exactly what's causing the alert. So Snort's running now. We're going to do those 2 scans again with NMAP and hping, and I want to show you something. So when we do the Christmas scan with NMAP, which is little s, big X, you can see that Snort alerts and says, hey, there's an NMAP Christmas scan detected. Now, the reason Snort is saying specifically NMAP Christmas scan is because the flags that are set are just fin, urge, and push. Now watch this. I'm going to do a scan with hping, and I'm going to set all the primary flags, which is what we did here. When I do that, and then we'll stop it, you will see that Snort alerted to that as well. But look at the difference. With the first scan, it specifically said an NMAP Christmas scan is detected. And with the second one, it just says Christmas attack detected. How does Snort know the difference? It's because with the hping, we had the 6 primary flags set, whereas with NMAP, we only had 3 flags set. Let's look at the results of this. Let's stop Snort. And let's go actually look at the resulting log file that was created because of that. So if I go to Snort log, and we want this one because that's the one that was just created. And since it's a PCAP file, we can drag it right onto Wireshark, and Wireshark will open it just fine. go. So now we can drag it to the icon. So let's look at the results. This is why Snort said Nmap Christmas versus just Christmas. The first one had just fin, push, and urge set. But then if you look down, the second one that caused an alert had fin, send, reset, push, ack, and urge set. That's my HPing scan. So this is why there's confusion out there about what a Christmas scan is. When we're talking Nmap specifically, Christmas is just fin, push, and urge. But when we're talking in general, we could be talking about what we see here with HPing, where we set the 6 primary flags. So that should clear up a lot of confusion for some of the stuff that's out there in the industry about this. But that's what the difference is between those. Now, back to our scan flags. Next, we're going to do a fin scan with Nmap. And we're just going to do SF like so. We'll start a new Wireshark capture. We will use our same filter that we used earlier. And what we will see here is that, of course, the only flag to set is fin. And since, again, that's out of sequence, you're not starting with a send, Nmap simply responds to that with a reset. Or excuse me, the victim responds to that with the reset. And that lets us know that that port should be closed, but it's actually open. And this is, again, a Windows-only type response mechanism here. Okay? That's a fin scan. Now, the next type of scan that I want to show you is the one that Nmap does by default when you're root. And we looked at that in the previous section. That is a send stealth scan, which is little s big S. So if we look at what we have here now, we do that send stealth scan, we get the proper results. The port is indeed open. But now we can see that the way that it did that was Nmap sent a send, got back a send ack in response. And then it responded with the reset to close that session before it ever started. And that's part of where the term stealth comes in, is because it's not completing a connection. So it's less likely to be logged somewhere, or more likely depending on who's logging, right? So that is the send stealth scan. Moving right along to the next flag that I want to show, and this one is going to be considerably more involved. How would Nmap determine not only is there a service there, but what is a service? So let's go over and look at this FTP server that I've got running here. It's just open source FileZilla. I'm going to have it listen on the right port, and I'm going to give it its default banner settings here. So right now, if I FTP to that server, and we'll just telnet to it. To port 21, which is where the FTP is listening, notice it spits out this banner that tells me FileZilla version 0.9.50 beta. Well, that banner helps the attacker, or you, the pen tester, know what's running there. Also, the fact that it's listening on port 21 insinuates it's likely FTP, but it could be something else. All right. Now watch this. I'm going to change the port. So let's make it listen on a different port. And I'm going to change the banner to lie and say it's like some Cisco print server or something like that. Now, when we telnet to that machine to port 21, we get nothing because it's no longer listening on that port. But if we do port 500, we get a banner, but the banner doesn't say FTP FileZilla anymore. Now it says Cisco print server. So the average pen tester or hacker would be fooled by that and possibly think that this is a Cisco device here. But the question is there a way to make Nmap dig past that banner, dig past that default port, and tell you what it is anyways? And the answer is Yes. And the more important answer is, how does it do that? Like, that's what I want you to get. So if we go ahead and start a new packet capture, because I want you to see how it makes this determination. I'm going to introduce you now to the SV scan, or the version identification scan. And we're going to scan port 500. And notice it's going to take it a while, but it's still going to be able to tell us conclusively what the service is that's running there, because of the fact that it's not just trusting that fake banner. It's doing some other things. And what I want to show you is those other things that it's doing. And I think you'll agree it's pretty ingenious as to how Theodore coded this to do that. So yes, it absolutely was able to tell us, even though it's listing on port 500, even though the banner lies and says it's Cisco, it says, NMAP says, nope, it's a FileZilla FTP server, which is exactly what it is. Now, the important part is, let's go look over here and figure out how it did that. So the first thing NMAP did was it checked to see if the port was open. It did, so it connected to the port. Look at what it did first. I want you to think about the fact that this code was probably written in the early to mid 90s. Okay? Think about that time frame and tell me, when we talked about the internet networks, what was the primary thing on the internet at that time? Was it FTP servers? No, it was primarily just static web servers. So built into the DNA of NMAP, in other words, how it was coded back then, it's first going to check to see if this is a web server. So I'm going to go to find packet here because I want to show you what it did first. NMAP actually, and I'm going to grab that packet, you know how to do this from the TCP IP section. I'm just going to follow stream, and you can see that NMAP actually just did a standard HTTP GET request. This is what your web browser does every time you visit a website. So NMAP tried to pretend it was a web browser to see if this thing responded with a web page, and it didn't. It responded and said, I have no clue what you're talking about. It says command unrecognized. But NMAP didn't give up, because NMAP's convinced, like, look, most things that are on the internet's web servers, because back then it was. So what does it do next? Well, it tries another HTTP method or command, whatever you want to call it, called options. And again, when it did that, the victim responded and said, I have no idea what you're talking about. NMAP tried a whole bunch of different web server commands and methods like this. Finally, it gave up on the web server idea and decided to see if it could have possibly been a DNS server, because back then DNS servers were probably the second most common thing that we had on the backbone of the internet. So if I go to find again, we're going to see that it actually tried to do DNS bind commands. And it absolutely did try to do that. Now, finally, after trying a whole bunch of different commands like that, NMAP got tired, and it did what we often refuse to do. It asked for help. So finally, NMAP simply sent the string help. When it sent that string, the FTP server responded to that with, here are the commands that I know. NMAP took this list of commands, compared it to a services definition file that it has built in, and said, oh, these are FTP commands. So because it responded with, hey, I understand FTP commands to help, that means it's probably an FTP server. And further, in my services definition file, FileZilla is the only FTP server that I have any record of that says have a nice day when you disconnect from it. So not only do I know it's an FTP server, it's FileZilla FTP. And that's how we were able to get the answer, FileZilla FTP, even though the banner was forged to say something else, even though the port was changed to be a weird port. So the lesson there is, if you're a good pen tester, they shouldn't be able to hide services from you by changing the ports and changing the banners, because just regular old NMAP with an SV, a service identification flag, should dig that out for you. But I wanted to take the time to dig in to let you see exactly how NMAP did its service identification scans, because that's very important to understand. Now, when we look at those scan types, as we said, there's many different ones, and we've went through quite a few of them here. But what we're going to be doing next is we're going to get into some of the other secondary scan options. You know, things such as verbosity level, things such as how fast the scan goes and how slow it goes. And we're also going to be looking at several other things like how many ports you want to scan and all that. But master these foundational primary flags that determine the type of scan that you're doing first, and then you move on to the other stuff after that. Right? Now, let's go ahead and end it right there. Hope to see you in the next video right away, where we're going to be looking specifically at some of the more advanced and in-depth flags. Thank you.